It all started with this mixtral of experts, and now these mixture of expert models are the hot topic of today's generative AI. As soon as Mixtral 8 into 7 billion was released, a whole new slew of mixture of expert models were released, and to this date, almost every day we see a new mixture of expert model on Hugging Face. In this video, I'm going to show you 3 of my favorite mixture of expert models which are present on Hugging Face at the moment. Before I do that, just as a refresher, let me explain what exactly mixture of expert is in very simple words. The thing is that the scale of model is one of the very important angle for better model quality, and that is where we have this mixtral or mixture of different models. Mixture of experts enable models to be pre-trained with far less compute, which primarily means that you can dramatically scale up the model or data set with the same compute budget as a dense model. In particular, a mixture of expert model should achieve the same quality as its dense counterpart much faster during pre-training. Now, there are two parts of mixture of expert. First is sparse mixture of expert layer, and the other one is network or router. Sparse mixture of expert layer is used instead of dense feed forward network or FFN layer. Mixture of expert layers have a certain number of experts, for example 8 in the case of Mixtral, where each expert is a neural network. The experts are FFN, but they can also be more complex network. Whereas the second part, the router, determines which tokens are sent to which expert. Now, this is a very short overview of this mixture of expertise, but there are a lot of other good resources which you can check out, and even if you read this paper mixture of experts, you will get a very fair understanding. Another common terminology which you often would hear in terms of mixture of expert is sparsity. Sparsity uses the idea of conditional computation, whereas in other models which are non-mixture of experts, or in other words dense models, all the parameters are used for all the inputs, whereas sparsity allows us to only run some parts of the whole system. Okay, now having said that, now let's review what exactly the three model which I really like and which are also present in the Hugging Face LLM leaderboard are in terms of mixture of experts. The first model I want to give shout out is Phixtral by Maxime Lebon. This model is a real darling, I would say. Phixtral 4 into 28 is the first mixture of experts model made with 4 Microsoft Phi 2 models. This has been inspired by Mistral AI's Mixtral 8 into 7 billion architecture, and according to the various benchmarks on Hugging Face and other places, this has already shown that it can perform better than each individual expert. Also, as I said, that it has merged 2 or 4 Phi 2 coding fine tunes, and it is really awesome at coding for its size. And if you just take one benchmark such as AGI eval, it has already achieved 34 ranking on that benchmark. The next model which I really want to give a huge shout out is Mamba. This model I have already done couple of detailed videos. This model is state space model, which is different from transformer, and it is a recent, I should say, SSM or state space based model that achieves remarkable transformer like performance. And this model, mixture of expert Mamba, has already outperformed both Mamba and transform MoE. MoE-Mamba or mixture of expert Mamba has reached the same performance as Mamba in 2.2 times less training steps while preserving the inference performance gains of Mamba against the transformer. So a truly groundbreaking innovation in terms of mixture of experts plus this state space architecture. Also, this MoE-Mamba or mixture of expert Mamba comes with 416 million parameters with 26 million active at inference. As I said, it has combined MoE and SSM layer, and it has totally eliminated the attention layer. Also, according to some benchmarks, Mamba has scaled in a sparse architecture without quadratic attention cost, which is a huge saving. The third and final model which I want to give a huge shout out is DeepSeekMoE. Now, this DeepSeekMoE architecture, this leads towards ultimate expert specialization. It involves two principal strategies. First, it finally segments the expert into MN1s and activating MK from them, allowing for a more flexible combination of activated experts. Secondly, it has isolated KS experts as shared ones, aiming at capturing common knowledge and mitigating redundancy in routed experts. And this is a huge promising architecture which is building upon this mixture of expert one. Now, on various benchmarks, this DeepSeekMoE has approached the performance of its dense counterpart with the same number of total parameters, which set the upper bound for mixture of expert models. They have also scaled up this DeepSeek mixture of expert to 16 billion parameter and have shown that it achieves comparable performance with Llama 2 7 billion with only about 40% of computation, which is a huge difference. Now, as I said, that it also has introduced fine-grained expert segmentation and shared expert isolation to reduce expert redundancy. It has also shown quite a significant performance over traditional GS hard MoE architecture, such as which has been used in the phixtral. Now, this is it, guys. If you know of any mixture of expert model which you think should be in this list, please feel free to share it in the comments. Now, I think that this is going to be huge, and we are going to see more and more promising models which will be mixture of expert, and maybe they will be joined with this state space model architecture. I hope that you enjoyed it. If you have any questions or comments, please share them, and if you like the content, then please consider subscribing to the channel. Thank you very much.